Hi everyone. Welcome to day two of learning about geometric sequences and series. Today we're going to expand on the knowledge we learned last time about what a geometric sequence is. And we're also going to add on the idea of a geometric series, which means adding up all of the terms in the sequence. So today we're going to write geometric sequences, we're going to write geometric series, so a bunch of terms separated by addition, and we're going to learn fast ways to add them together. So today we're going to learn about a geometric series formula to find the sum, how to find the number of terms in a geometric sequence or series, and then some uses for it. So we'll start with a warm-up. Is this geometric? I'll give you a hint, it is geometric. So write a recursive definition and write the explicit definition. Practice both forms. Pause the video when you're ready. We'll look at it. We'll get into the extension today. Okay, so you tried them out. We'll take a look. Okay, see the multiplier is -5. So recursive to get from the previous term to the next term, -5 times g of n minus 1. And then you got to tell me the starting term is -4. And once again, the book would write it like g of n equals, and they would say -4 when n is 1. And when n is bigger than 1, we'd have -5 times g of n minus 1. And then explicit, we're in agreement. They just use a subscript instead of the parentheses. So -4 is my start, -5 is my multiplier. We start at the first term, that's where the n minus 1 comes from. Now, the geometric series is just these terms separated by addition. So it would be -4 plus 20 plus -100, and so on. Now, this is a series. A geometric series, like I said, is the sum of the terms. So S sub n means the sum. So the sum of these terms. And a long time ago, people would just add up all the terms by hand. So if there was 100 terms, they didn't have a formula for it, so they added the first term and the second term and the third term and the fourth term. We don't do that anymore because a famous mathematician came up with this idea of, hey, what happens if I use some sort of substitution and I wanted to solve and get it in terms of the first term and the multiplier? And he did so. So you don't have to copy down this whole slide, but I want you to see what he did, because this is how math is created. So he took the sum and multiplied it by the common ratio. So he knew there's common ratio r, and he multiplied every term by r. So if you see here, the orange term shifted and was our second term, now became our first term. And same thing, every term shifted 1 to the right. So this first sum has a1, and this last the second sum has this last term that the first one doesn't have. Everything else is in common. So he saw that if we can use elimination, we subtract down. So he subtracted, and those are going to cancel out, and those are going to cancel out, and those are going to cancel out, and those are going to cancel out. Okay, so we can subtract down, and we have the sum minus r times the sum, and we have the first term, a of 1, minus a1 times r to the n. Now we're trying to find the sum here. We're trying to isolate the sum. So what he did was he factored. He factored the sum on the left side, and he factored the first term out of the two terms on the right side. And then he divided by 1 minus r to get the sum by itself. And we see this equation, which this is the equation you need to have and understand that this, if I tell it a number of terms, okay, so I can say the sum of the first 10 terms, the first 37 terms, or the first 146 terms. I don't need to count every term. This formula will take all of the details into account as long as I know the first term, the common ratio, and how many terms I want to add up. Okay, and this formula is very helpful because it saves a lot of time, especially if computers are asked to add up the first 500 terms. I really don't want to do that one at a time. So what we see here is this is the summation symbol. Now, you probably have encountered it previously, but if not, here's a quick recap. Okay, this tells me to add up terms 1 through 7. So the first term, the second term, all the way through 7. So when it says write the expanded form, I see the first term is 3, and then I multiply by 2/3 to get the second term. So 3 times 2/3 is 2. I multiply that by 2/3. I multiply that by 2/3. And so on until I get all 7 terms. And then I can add them up by hand. Now, I really don't want to do that. I mean, if it's only 7 terms, I can. But if it says just what is the sum, I can say, well, the sum, I can use the formula in the previous slide. Okay, take the first term times 1 minus r to the n over 1 minus r. Now I have all the details in here. Okay, I know the first term is 3, so it's asking the sum of the first 7 terms. Okay, first term is 3. My ratio is 2/3. I want to the 7th power because there's 7 terms. It's saying add up the first 7 terms over 1 minus r. And I can put that whole number in my calculator. And I want you to practice using that calculator. Okay, a calculator can do this all at once. Now I put parentheses in very specific locations. Okay, I'm not distributing. I'm letting my calculator do all the work. And you may want to put your denominator in parentheses. Okay, that's generally a very good idea. So now I can add up 3 plus 2 plus 4/3 plus 8/9 these 7 terms to see if you can get an answer. Or I can use this formula and get an answer. And either or, I get 2059 over 243, or if they want a decimal, my calculator will give me that too. Okay, both ways work. If it's 7 terms, both ways take about the same amount of time. But like I've said in the past, if it's 500 terms, I don't want to write out the first 500 terms. I want to use the formula. So it could ask me, what's the sum? I could also be asked another thing, but let's try this one first. I want you to expand it, write the first 5 terms, find the sum. Okay, and the second one, I also want you to practice, can you write it in the summation symbol with the letter sigma? So when it says sigma notation, go ahead and find the sum. Pause the video when you're ready. Let's take a look. Okay, let's see how you did. So expanded form, I have 1/2, then times 3 is 3/2, 9/2, 27/2, 81/2. I got the first 5 terms. Or I could put it into the formula. In both ways, I get 121 over 2. Now, if it wants in sigma notation, the second one, okay, I need to figure out that this is the 5th term. So we've done that previously. And then I got to say, okay, I want it to add up this. And using the formula, I can get -728 over 243. Now your calculator will also allow you to use sigma notation, but as I've learned, it's really complicated. So understanding this formula and putting the formula in really is helpful to find the sum. In this case, you need to know that the last term is the 5th term. Now they can also ask how many terms. Okay, so which term is this? Is this term 8 or 9 or 10 or 11? Once again, I don't want to count up. I do know that the first term is 200, and I can figure out my multiplier, which will really help. That multiplier is 1.5. And here's how we go about this. So we can write an explicit equation for this. So I write out this sum. Okay, as an example, we know that the first term is 200 and the multiplier, the common ratio, is 1.5. So I can write an explicit equation. Now my goal is to solve for n. So I know that the last term is this, 7688.7. And now I'm going to use algebra to solve. And I'm going to go through this pretty fast. I'm going to stop at 1 point because 1 point is really important. But we need to know how to solve for n. So we divide by 200 on both sides. And then we see n in a variable, which we've learned how to deal with this chapter. So we take the log of both sides. And we can use the power rule. Now, I don't want us to get scared about decimals or big numbers. Calculator can handle all that. Our job is to solve it algebraically, then put one thing in the calculator at the end. So now we got to get n by itself, so we got to divide. We need to add. And then we have a whole expression that's equal to n. And we put that in our calculator, we get 10. So that is the 10th term. There's 10 terms in this series. 7688.7 is the 10th term. I did not need to count up and find term 4, 5, 6, 7, 8, or 9. I don't want to do that. So they can give us the series itself and ask us which term number is that. We also could be tasked with, they give us the sum and maybe then the first term and the ratio and how many, we got to find out how many terms. We still got to solve for n. But in this case, we're just going to use the other formula that we just learned today. We're going to use the sum formula where we know the sum and we know the first term and we know the ratio, but we don't know n. So when in doubt, think of a formula that's going to help us and then substitute the values in. Okay, now it's a lot of algebra. We're going to use logarithms again, but most of the steps are algebra. I substitute the numbers, I did 1 minus 5, I simplified the denominator. And then here's a lot of steps. I multiply both sides by -4, I divide both sides by 3, I subtract by 1 on both sides, I divide by -1 to get an expression that I'm used to. Okay, goal is get n by itself. Anything I can do, I'm going to do to simplify. Now I can take the log of both sides. Now I can divide and get n by itself. And the more I practice this, okay, the quicker these steps go for me. I'm not expecting anyone to do this in 5 or 10 seconds, but we should be able to see, oh, when do I have to multiply? When do I have to divide or add or subtract? Those are the steps that we've practiced and got really good at. The logarithms are the new step that we've added on. And we get that this series has 6 terms. Okay, be 3, then ratio is 5, so 3, 15, 75, so on. And then the sum would be 11,718. And now it is your turn. Okay, you're going to try one of each. How many terms are there? And in both cases, if I give you the series itself, or if I give you the first term, the ratio, and the sum. Pause the video, take 5 or so minutes, try it out, see how you did. We'll see the answers momentarily. Okay, hopefully we went 2 for 2. Okay, first one, we needed to come up with the geometric sequence, the explicit form, and then solve for n using logarithms. The second one, we needed to use the sum formula. We knew the first term and the ratio, and we needed to solve for n. And at this case, the second one, I didn't even use logs. Okay, when I got to 32 equals 2 to the n, I know 2 to the fifth power is 32. You could take the log of both sides, but I'm not going to do that. If I can see an answer, I can look inside and just tell what n is. Okay, the algebra is when we need a little extra help or if the numbers are stuff that we're not familiar with. So in this lesson, we learned about recursive formula. We learned about explicit formula. We learned how to find the sum. Okay, and that sum formula helped us if we need to find how many terms. Same thing with the explicit. Okay, so geometric sequences and series are helpful when you have a sequence of terms or a collection of terms that are separated by multiplication. And there's plenty of things we can do with geometric sequences and series.